Hey, so I want to show you something cool today. What you see here is an image of the architecture of this project called HDF5 UDF, UDF standing for user-defined functions, and HDF5 standing for the hierarchical data format, which is a file format that's quite common in the scientific community. So on the left-hand side of this image, what you see is the typical path that the data takes when you're writing and reading datasets to disk. So you basically write the entire grid, say, to disk. And on the right-hand side, what you have is the path that the data takes when it's taking the UDF path. So what we do here is we have three different backends that let the user provide source code, such as C++ or Lua or Python. And we take that code, we compile the code into a bytecode form or into a shared library in the case of C++. And then when the application requests to read that dataset, we simply load that precompiled routine from disk and we execute it, and the result is provided to the application. So one cool thing that we can do here is to make some use of the expressiveness of a programming language that's embedded on the UDF and reach out, say, to the internet to get data that's hosted elsewhere. And it is also possible to do something really out of the box, such as interacting with applications that are running on the same computer, such as what I'm going to show you right now. So in this example, what I'm doing is creating a UDF file that contacts a modified version of the Doom game. So what I have here is a UDF file that basically talks to the modified engine of Doom, and it retrieves both the Framebuffer and the palette so that the colors can be recovered from the scene that's captured from the game. And you can see that we are doing this by attaching to a shared memory segment that's exported by the modified game, and then we simply copy the results to the dataset that the application requests. So let me show you what's happening here. So this HDF5 UDF utility basically takes a existing HDF5 file along with this source code, and then I just declare the name of the variables that I want to access along with their dimensions and data types. So when I run this, I compile on the fly this code into a user-defined function. You can see that it's quite small, it's just 5 kilobytes. And I have one data set for the Framebuffer, another for the palette. And then next what I have here is a script, or a utility actually, that given an HDF5 file and a data set name, it prints the data to the console. And in this case we use Truecolor ANSI escape codes to get the data from the palette and print the frame of the game in a nice fashion on the console. So what I'm going to show you next is this script that basically calls the read h5 utility in a loop, and it's going to be rendered on a small window, on an xterm window with a tiny font, size 2, so you can see the screen better. So let me show you. And now I'm gonna launch the game. And voila! Yeah, you can see that I am a terrible player, but the idea here is to show what's possible to do with the UDF framework that's been put together here. So even though nobody's going to actually play Doom through this framework, it is possible to see which kind of possibilities the framework opens for those wanting to host the data on HDF5. So yeah, I'm happy to have had your time here, so please feel free to reach out to me if you have any questions. Thanks.